Hello out there. This is your hopefully helpful video on how to complete homework V2, so homework book volume 2. If you have volume 1, it will not go as high as pages 129, 133, 135. And tomorrow I'll do one for these pages here. Now, if you're unable to do these tonight, it's not a big deal. Just do your best to get all these done by Friday if you can. And if you can't, oh well, I'll get them next week. Anyway, so it's a review, which hopefully will help. But I do want us to practice with some unit fractions before we enter summer, because fractions are a big part of fifth grade. They'll build upon this next year. So when we talk about sum, it's either add, subtract, multiply, or divide. Hopefully you remember that sum is the result of addition. Now unit fractions, hopefully you recall, any fraction that has a number, a numerator over a denominator. If the denominator is 3 and the numerator is 1, that's a unit fraction. If the denominator is 5 and the numerator is 3, that is not a unit fraction, because these are all sum of unit fractions. For example, 3/5 is the sum of 1/5 plus another fifth plus another fifth. Now that's 1 unit, 1 unit, and 1 unit. And when you put them together, you get 3/5. So that's what you're going to do. And just so you know, for these, I'm only going to do the prime numbers. And the numbers that are prime are 2, 3, 5, 7, 11, and of these, 13. So I'll do these, and then you'll do the rest. So first, 5/8 is the sum of unit fractions. The denominator has to be 8, and I'm going to do 5 of them. 1, 2, 3, 4, 5. And then unit fractions means an eighth, and an eighth, and an eighth, and an eighth, and one more eighth, right? That's the sum. I added 5 unit fractions with eighths. 2/6, oh, short. 1/6 and 1/6. 4/12. I need the denominator 12 4 times. One more time. Okay. So 1, 2, 3, 4, 1/12 equals that. And then 8/12. Boy, it's like this. Too bad I can't just add these together, right? 12, 1/12 plus 1/12. Plus another 12th, and I'm getting tired of 12ths, but that's okay. 1, 2, 3, 4, 5, 6, 7, 8. Boy, who do they think can fit 8/12ths on that short little line? Huh? What do you say, everyday math? Is that what this is, everyday math? Math expressions, blah, blah, blah. All right, so 1, 2, 3, 4, 5, 6, 7, 8. 1/12 equals 8/12. And down here, you are you're adding it, so you have to add up these and produce the sum. So speaking of eighths, 1, 2, 3, 4, 4/8. But in 5th grade, your teacher will be much more pleased if you can say 4/8 in simplest form. 2/4 is better, but a half is best, right? Because if you have something like this, this is 2 out of 4, just like this is. Is this right? That's way too big. That's my favorite mistake of the afternoon. All right, so I've got halves, fourths. How do I make these eighths? 1, 2, 3, 4, 5, 6, 7, 8. Pretty close. 1, 2, 3, 4, 5, 6, 7, 8. All right, so 1, 2, 3, 4. 1, 2, 3, 4. So that's 4/8. So there you go. 4/8, 2/4, 1/2. Best answer, 1/2. All right, where else were we? Oh, a 12th. A 12th and a 12th is 2/12. And another way to do this is, if you know 2 and 12, both of these numbers are 2 times 1 and 2 times 6. So you can take this and say bye-bye, because 1/6 is 2/12 in simplest form. I don't know that you're upper grade teachers will require or even appreciate that, but I know I do. Har har. All right, so 2/12 is a half. The other page you had to do was 133. And very similar. If you have 4/8 and you add another 2/8, you have 6/8, which is fine. But if you remember factoring sixes, 6 is 2 times 3, and 8 is 2 times 4, so the best answer is just to do 3/4. Oops, 1 is not prime. 2 is prime. 3 and 6 equals 9, and 11 is the same, so that's a denominator. Can't factor those. 3/4 decreased by 2/4 is 1/4. That's already simplest form. Another problem that's prime is 2/6 plus a 6 is 6, and some of you see that 3/6 is the same as 1/2, right? Because 3 is half of 6, just like 1 is half of 2. What's another prime number? 7. 5 and 4 is 9. Is 9/12 in simplest form? Not yet. 9 is 3 times 3. 12 is 3 times 4. So that is the best answer. And what's another prime number? Oh, 11. When Kashan sharpens her pencil, she loses 1/12. One day she sharpened it 3 times, the next day 5 times. What fraction of the pencil did they sharpen away? All right, so I don't know, draw a picture. So every time they cut it, they lose a 12th, right? Not a half, a 12th. All right, so day 1, they lose 3/12. And day 2, they lose 5/12 of the pencil. So you put those together, you're going to have this. 8/12 was sharpened away, but 8 is actually the product of, so I could do 2 and 4, and this could be 2 and 6. 4 and 6 could be simplified to divide both by 2, and I get 2/3. So, Kashan, is that a she? Oh, whoops. Kashan sharpens. And if you do, where is it, 8/12? If you do 8/12, it's okay because that is correct. You could put AKA 2/3. Oops, thirds. There. Sharpens. Sharpened. Sharpened. Good enough. What was next? 13? Oh, 13. All right, so there's an orange. They cut it into 8s. If you cut it in half, that's half. Another half, that's 4ths. Is this right? 1, 2, 3, 4, 5, 6, 7, 8. Pretty good. She ate 3. 1, 2, 3. The other friend ate 3. 1, 2, 3. So what's left? That many. 2 over, remember there were 8? So did they eat the whole orange? Not yet. There is still 2/8. Or, do you remember how to make this simplest form? Divide by 2. So 2 times 1 and 2 times 4. That's how you make 8s. So divide by 2, you get a 4th, or 1/4 left. Okay, so that's how you do those problems. Oh, but there was this one too, though. So let's see, I think it's 135. Can I double check? Yeah, so 135. Equivalent fractions. So what you may remember is that if you have, let's say 2, all right, 2 is a prime number. So if you have 2 and 3/8, so you have a supergiant 1 and a supergiant 1 and 3/8 left over. Hidden in this supergiant 1 are 8/8. There's 8/8 in there too. So there's 8 and 8, which is 16, 17, 18, 19. So there's 19 eighths. That's how you do that. The other method, if you have 2 and 3/8, is you say 2 times 8 is 16, 17, 18, 19. Either way, it's that. Okay? Some visual learners like to see it this way. Others like to see it this way. Whichever way your brain sees it is great. So for this, I'll do it this way first. So 4 and 6 sevenths. 4 times 7 is 28 sevenths plus another 6 sevenths. So 28 plus 2 will give me 30. And then there's 4 left over, so I think it's 34 sevenths. All right? Yep, because 8 plus 4 is, sorry, 8 plus 6 is 14. I think. It's pretty late. All right, so what's next? 5 is a prime number. 3 and 7 tenths. 1, 2, 3, and then 7 tenths. So these are all tenths. 10 tenths, 10 tenths, 10 tenths. 10, 20, 30, 7. 37 tenths. Boop. Yeah, remember it's 3 times 7, 30 plus 7 more, 37. And then last up here, 7 times 4 is 28, 29, 30, 31. So this is 31 fourths. Boop. All right, what else is here? 9 is not prime. 11 is prime. All right, so for this, you do the other way around. You do the inverse operation. You could, if you wanted to, you could take 23 and say I can take out 4 fourths. That brings it down to 19. Another 4 fourths would be minus 4 is 15. And another fourth is 11. And another fourth is 8 or 7. 11 minus 4 is 7. And then another 4 is 3. So it's this and 3 fourths. 1, 2, 3, 4, 5. I think. So let's the other way to do this. This is not as clear, right? Supergiant ones. See this? That's not as clear as this method. If you have 23 fourths, the numerator is your dividend, 23. Your divisor, right? The divisor, or sorry, denominator is your divisor. So 23 over 4 is the same as 23 divided by 4. 4 goes into 23 5 times with 3 fourths left over. 1, 2, 3, 4, 5. I did okay that way. But I think 5 and 3 fourths using the long division method is probably easier. Let's try another one. What's prime? Oh, here, 13 is prime. So 21 over 8. So it means you have 21 of something, and you're going to share it in groups of 8. 21, and I remember it goes 8, 16, 24. It's not 3, it's 2, because 8 times 2, 16, and 5. So 2 and 5 eighths. 2 and 5 eighths. Okay. 17 is prime, so I have to help you with this one. All right. Castor brought 6 and 3/4 small carrot cakes to share with their 26 classmates. Did they bring enough for everybody to have a fourth? Well, this is another good, oops, sorry, I couldn't see that. So here's a good example of 6 and 3/4 cakes, right? 1, 2, 3, 4, 5, 6. Okay, why are they not bringing 7 cakes? I wonder if Castor couldn't help themselves and Castor had that slice last night. Well, in any case, so they have 6 whole pieces. That's a whole cake. Carrot cake, 1, 2, 3, 4, 5, 6 whole carrot cakes. And the last one has 3/4. 1, 2, 3 out of the 4. Is that enough for 26? Because, I mean, we could cut these really small, but you're supposed to cut them into fourths. Fourths, 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 right? So how many fourths is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 21, 22, 23, 24, 25, 26, 27. Woo! That was close. That was close. It's a good thing. Well, blah, blah, blah. I don't want to judge Castor. They made the cakes. They should get to have one. Anyway, do they have enough? Looks like yes. Okay. The other way to double check is if you have 6 and 3/4. Remember, you can multiply those two. 6 times 4 is 24 plus another 3/4. And 24 plus 3 is 27. So yeah, Castor has 27 slices of 1/4 carrot cake. So that's enough for Castor's 26 classmates and Castor, but if there's a teacher, no, nothing for the teacher. That's okay. Teacher probably shouldn't have any more sweets anyway. Sometimes they binge eat chocolate. Oh, sorry, I'm projecting a little bit. So that is how you complete the problems on 129, 133, and 135. And then tomorrow I'll do a video on those 3. All right. I hope that helped everybody. Aloha and au revoir.